Okay, let's go through some review questions for Chapter 7, the Jovian Planets. Here's question number 1. Both Jupiter and Saturn, A, have liquid metallic hydrogen in their interiors, B, have rings, C, emit more energy than they absorb from the Sun, D, rotate very rapidly. Well, they both have liquid metallic hydrogen in their interiors. That's the major cause of their large magnetic fields. They both have rings, even though Jupiter's doesn't show it on this picture, but all the Jovians have rings. Jupiter's is very faint. And they emit more energy than they absorb from the Sun. Jupiter's is probably from its residual formation energy. And they rotate very rapidly. They rotate on the order of 10 hours as opposed to our 24-hour day. So all the above are true for Jupiter and Saturn. Question number 2. The Jovian planets share all the following traits except, well, they all have differential rotation. They all rotate differently at the equator than they do the poles. In case of Jupiter and Saturn, it's faster at the equator than the poles. In the case of Uranus and Neptune, it's slower at the equator than the poles. But in either case, it's differential rotation. All of them have many moons. They have at least, I guess, on the order of 11 or more moons. All of them have lots of hydrogen and helium gas. All the atmospheres of the Jovian planets are comprised mainly of hydrogen and helium. And B, they have large magnetic fields. Jupiter and Saturn having huge magnetic fields. Jupiter being about 20,000 times the magnetic field of the Earth, Saturn about 1,000 times. But Uranus and Neptune have 100 times the magnetic field of the Earth. So B, C, D, and E are all correct. A low-density gaseous core, no. The Jovians have real dense solid cores, probably more dense than the Earth itself. So they do not have a low-density gaseous core. Here's question number 3. Jupiter and the other Jovian planets are noticeably oblate because they have, well, oblate means that they're kind of egg-like shaped. Their diameter is shorter between the poles than it is at the equator. It's kind of pronounced out here. And the reason is because of the rapid rotation. The centrifugal force of rotating faster has pushed the gas out more and made the planets appear oblate. And hence, the answer would be C, rapid rotation and a fluid interior. Here's question number 4. What is the probable source of the variations in Jupiter's belts and zones? Well, Jupiter has this rapid rotation causing a very fast speeds associated with the gases. And there are undercurrents, convection currents, as a result of that, with the high speed and the difference in latitudes of this high speed, causing a convection type action going on. So for Jupiter, you can see these bands as a definite result of differential rotation and the underlying zonal flow. Question 5. What is the source of Jupiter's large magnetic field? Well, probably the source of all the Jovian large magnetic fields is the fact that in their interior they have hydrogen in its different forms, but hydrogen being actually a metal. We never think of hydrogen as a metal because we always see it in its gaseous form. But if it's under pressure and under a higher temperature, it can actually be in its solid form or liquid form as well as a liquid metal. And so we have metallic hydrogen swirling in the interior of Jupiter, causing its magnetic field. Question 6. Saturn radiates even more excess energy than Jupiter because, well, Saturn has a heat mechanism, and basically it is the fact that it has helium rain. It's got less helium in its outer atmosphere, so it's believed that that helium is condensing and raining towards the core of Saturn. So as it condenses, it gives off more heat, just like what would happen on Earth when you have storm systems near the equator of Earth and a lot of energy associated with that. As those storm systems condense, that gives off heat. A lot of that heat is generated into the storm systems, which cause hurricanes on Earth. But for Saturn, it's just heat that is given off, and hence this mechanism is helium rain giving off heat as it falls toward the center of Saturn. Question 7. The two outer Jovian planets appear bluish in color because, and here's pictures of the two outer Jovian planets. You have Uranus on the left here and Neptune on the right. They're using the Voyager picture of Uranus. The more recent pictures of Uranus will show more of a band structure, but in either case, they're kind of bluish green in color. And this is because in their atmospheres, they have methane. Methane absorbs red light and gives off or gives the appearance more of a bluish color. So because of the presence of methane, 2% in Uranus and 3% in Neptune, that absorbs red light, giving off a more bluish color, and that's why they appear blue. Question 8. Which of these is true about the seasons on Uranus? Uranus takes 84 years to go around the Sun, and it's tilted 98 degrees, so it's tilted almost a right angle, so that its axis is almost directed right along the ecliptic plane. So there's going to be the one pole of the Uranus is going to be facing towards the Sun for 42 years, and then the other pole is going to be facing towards the Sun for 42 years. Hence, there's going to be more of a dramatic seasonal variation on Uranus as a function of years. So you're going to have a strange tilt produces extreme seasonal variations. Very mild when the pole is towards the Sun, because all of the spin of Uranus is perpendicular to the direction from the Sun. Hence, all Uranus would get pretty much the same amount of insolation. But in 2007, it's sideways, and now that's distributed over the whole planet, and you can see band structures and storms and other unusual things happening, more dramatic changes. Question 9. The magnetic fields of which two planets are most unusual? Well, Voyager 2 measured the magnetic fields of the Jovian planets. Jupiter and Saturn were, as expected, the magnetic fields were along the axis of rotation of the planets, hence confirming what would be called the dynamo effect. If you had metallic material on the interior of those planets swirling around, it would produce a magnetic field emanating very close to the axis of rotation of the planets. However, this did not happen with Uranus and Neptune. The axis of rotations were in different directions, and the magnetic fields were quite different from those axes of rotation. For Uranus, it was 60 degrees in the opposite direction from the rotation axis. For Neptune, it's 46 degrees from the rotation axis to the magnetic field axis. This is quite a mystery why these planets would not have the dynamo effect occurring, and that would be something for future investigations to discern. I tell my class that I have my own theory, which is that by the time Voyager got to these planets, its measurement of the actual axis of the magnetic field was frozen and did not make good measurements on these two planets. That concludes the clicker questions on Chapter 7, and hope this was a very good review for your upcoming quiz.